using how to use a sling psychrometer. And what we get from that particular type of device, we're going to be measuring relative humidity or percent RH, and then measuring dew point temperature. Both can be measured with a pretty simple device. This is what a sling psychrometer looks like. The handle up here on the right hand side, it's been extended, and so usually it sits, the whole device here, this whole thing slides back into the handle, but you'll notice there are some things, numbers, increments we can read, relative humidity off of this handle. I'm going to show you how to calculate it using a different set of tables. Okay? But the basic principle here is that we have two thermometers, and those thermometers are going to be measuring temperature basically at the same time. Okay? The one on the right has this little sock on it, and that little sock is what we're going to get wet. Okay? So we get the sock wet, and then we get reading also from this, which is a dry thermometer. So we have what's called the wet bulb and the dry bulb thermometers. We are going to sling them around, hence sling psychrometer, and we're going to cause evaporation to occur here. Now, evaporation involves the removal of heat from the system. Okay, so as water from the sock, which is liquid, goes to vapor, it's going to absorb some heat. Okay, and this is what we call evaporative cooling. Okay. So this is the same phenomenon. If you go outside in the summertime and you're going to go for a run, it's quite humid outside, you start to sweat, but you don't feel like you're cooling down. That's because there's already a lot of humidity in the air, and so you're going to stay pretty hot. If you go out in a climate that's dry, so you went to this, the southwest U.S. and Nevada, Arizona, a place like that, where there's not a lot of humidity, you go for a run and it's 100 degrees out, you're going to get a stronger cooling effect because the air can take that moisture from your body, and as it leaves your body as vapor, it absorbs heat and gives you the sense that you're sort of cooling off. In fact, you are cooling off through this process. So I thought we'd just watch a quick video on what the psychrometer looks like. They come in a lot of different forms, and we can simply go ahead and watch a short video, and I'll narrate this particular video that's been made. So it's just a quick demonstration. There are a couple of different kinds that are shown here. We've got the sort of very inexpensive kind, and then a more robust set of thermometers. You dip the sock covered thermometer into some water. You don't really want to dip the dry bulb in because you don't want any cooling on the dry bulb that's related to evaporative cooling. Okay? And then you're going to essentially spin the thermometer or set of thermometers for about a minute. You need to do it for a minimum amount of time, a minute, 2 minutes, with the idea that it's going to reach equilibrium. So if we just back up for a second. He's spinning it up here. There he goes. You can see it. You stop spinning it. Now you're going to read the dry bulb. You're going to read the wet bulb. Okay, and those temperatures should be subtly different. In this example, the dry bulb is reading 24, and then we'll just play it forward here a little bit, and we get the wet bulb reading 21 degrees. So it's actually pretty humid out because the temperature hasn't been depressed very far, and that's 76 degrees relative humidity. I'm going to go ahead and pause this and get out of here. And I'm going to show you how to read these values off of a chart or a diagram. So here's an example of a relative humidity table. Okay, it has a couple bits of information that we want to note when we're calculating or reading relative humidity from a sling psychrometer. The first is that on the left-hand side, we've got dry bulb temperature, and we have it measure a measurement in either Celsius or Fahrenheit. So we need to pay attention to what the sling psychrometer is measuring. Is it measuring degrees Celsius temperature, or is it measuring degrees Fahrenheit? At the top, we have the depression, okay, the wet bulb depression. So that's a calculation. Okay, the left-hand side is something you read straight from the thermometer. The top part of this is the top column headings are going to be measured as a calculation, dry bulb minus wet bulb temperature. So let's say we go outside, we sling our psychrometer around, okay? We end up with a dry bulb temperature. We're going to get a wet bulb temperature. We're going to get a difference, okay, between those two. And then we're going to get a percent RH down here at the bottom. So let's say we read 34 degrees Celsius for our dry bulb, and at the same time we read 20 degrees Celsius for our wet bulb. The difference between those two is 14 degrees Celsius. So we come down to 34 degrees for our dry, okay? And we got to come all the way over here, 14 for our wet. We come over and down, and we end up right here at 26% RH. So the relative humidity when the wet bulb is depressed by 14 degrees is 26% relative humidity. Okay. In this case, though, we could change the numbers around quite a bit. The farther the bulb is depressed in temperature, the lower the humidity is going to be, the smaller the humidity. So a big depression means a lot of evaporative cooling, and it means temperature is going to fall quite a bit. So let's take an example, another example. Here's 18 degrees Celsius. Let's say we read that off of our dry bulb, and we read off of our wet bulb. At the same time, we did our sling psychrometer, 16 degrees Celsius. The depression there is 2 degrees Celsius, right? So we'll go up to the dry bulb at 18, come over to 2, and we end up with 81% RH, or relative humidity. Now we can do the same calculation for dew point. Okay, so this is a different table. Just back up for a second. Note, different table. Okay, but the same principles apply. We're going to have dry and wet. Okay, we're still using the psychrometer to do this. We're going to have a difference between those two, and then we're going to have dew point temperature. Okay, so we're reading temperatures for the dew point rather than percentages off of this diagram. If we run the psychrometer experiment, we end up with 25 degrees Celsius, let's say for our dry bulb, 20 degrees Celsius for our wet bulb, and a 5-degree difference, okay, 5 degrees Celsius. You'll notice here there is no 25 degrees Celsius dry bulb measurement, so we're just going to go between 26 and 24. 5-degree depression puts us right here, 17 to 19 degrees Celsius. So we're just going to go with 18 degrees Celsius. So what that means is that at current conditions, whatever it is when I ran the experiment, okay, at 25 degrees, whatever the percent RH it was, I need to cool it down to 18. To cool the air needs to be cooled down to 18 degrees Celsius before we'll reach saturation. Do one more experiment here. We do our experiment. We get 10 degrees Celsius. On the dry bulb, we get 4 degrees Celsius. On the wet bulb, the difference is 6 degrees Celsius. Okay, and so we'll come over here to 10. Okay, come over to 6, which is right about here. Read down, and we end up with a value of minus 5 degrees Celsius. So if it's 10 degrees outside and the wet bulb is depressed by 6 degrees Celsius, the dew point temperature is going to be minus 5 degrees. Okay? On this particular table, where you're not going to do the experiment in class, and you could, if you want to, using two thermometers, and feel free to send me an email and let me know if you're interested. But for our purposes here, you're just going to sort of read these measurements. So you got a dry bulb here, and you got a wet bulb measurement there. And for each of these, you're going to do a calculation of relative humidity and dew point, okay, on the right-hand side, just like I did on the previous slides. So you'll do that for each of these. You'll do relative humidity and dew point, and you're going to read those values straight off of these two tables and then plot them up in this table here. Okay? So that's basically how to read and calculate relative humidity and dew point temperature using a sling psychrometer.